Today I'm going to introduce you guys to the idea of a log. I'm going to get real with you. This is going to be a very strange thing when you first see it. I want you to do your best. Email me with questions. It's not that it's overly challenging, it just looks different. And sometimes things that look different can be very scary to us. As you practice with logs more, if you're really doing the work the right way, you're going to feel very good with everything by the end of the week. It's just a matter of getting yourself acclimated to what this looks like. So, in order to understand what a log is, we're going to actually talk about exponents first. These two go hand in hand because a log is actually the inverse of an exponential function. But if I gave you this question right here and I said solve for x, you just learned how we can get the same base on each side. If you remember from last week, so 2 weeks ago when you weren't on spring break, we can get the same base because 81 is really 3 to the fourth power. So if we got the same base, we can set these exponents equal to each other, and we would get that x is equal to 4. When we talk about logs is really talking about the exponent some base needs to be raised to equal a number. In this case, the exponent's 4 and the base is 3 because 3 to the fourth power is going to equal this number of 81. So we're really just looking for exponents when you see the word log. And you're going to hear me use this terminology, circle of life. And I'll explain what that means in just a moment. But the circle of life is going to help us find what exponent we're looking for. Now, what is log form? When you have something that looks like this is what we call exponential form. You are going to be asked many times to write things in log form. A log form is when you take the log and whatever the base number is of your exponential form, that becomes the base number of your log. So you're basically going to write this word log with a little subscript, and that subscript will be 3. Now, you're going to put the equal sign, and on the other side of the equal sign, you are going to put the exponent from the exponential form, which in this case was the x. To the right of the log with the base of 3, you're going to put this value 81. We call this the argument of the log, which I think you'll see written down formally later on in the notes. This is wacky, but these two things mean the same thing. One is called exponential form. One is called log form. So this right here is log form. Log is short for logarithm. Now, I talked to you guys about this idea of the circle of life. The circle of life says that you start at the base of the log, you go over the equal sign, and that becomes the exponent on that base, and it's going to equal the number that is to the right of the log. 3 to the x power equals 81. That's exactly what it says up here in pink. So I know that this is super strange. I know that that's probably very confusing, but I think the best thing to do is just to practice, evaluate, do some examples, and then I think you'll start seeing what I mean by the circle of life. So let's look at the first examples. If you guys are asked to evaluate and it's in log form, you want to think circle of life every single time. Now, you're going to start at the base of the log, which in this case is 4, and think 4 to what power equals 16. A lot of time when I do these problems, I'll put equals x. So I'm really thinking 4 to the x power equals 16. And I'll rewrite this in exponential form. Now, once you get rid of the thing that scares you, the fact that it says log, you get this in exponential form. This is what you've already learned. 4 to what power is 16? For a lot of you guys, right away, you can get that answer is 2. But if you need to, think about what we did 2 weeks ago. Get the same base on each side And then once you get the same base, set those bases equal to each other, or I'm sorry, the exponents equal to each other since the bases are the same, and you get that value of x equal to 2. Let's do the next question. With the next question, you want to think, just set it equal to x, 2 to what power is equal to 8? So use the circle of life. You start at the base, 2, go over the equals to the x power equals 8. Right away, you can see 2 to what power is 8. Some of you might be getting, oh yeah, 2 cubed. It's got to be 3. Alternatively, though, you can also just get the same base on each side, and then that is the exponent that we are looking for. Moving on to the next problem here, you will see 7 to what power is equaling 7. So write it out if you have to. 7 to the x power equals 7. Well, we already have the same base, so x has to equal 1. 7 to the first power is equal to 7. And then for question D, we have equaling x, 5 to what power equals 125. If you can't get it right away, think about getting the same base. I know that 125 is 5 cubed, so I get this answer of 3. So x equals 3 or just 3. You can put x equals or just 3. Either one I will accept. Now, that's really it. Notice all of these answers were really just an exponent. The exponent that the base needs to be raised to equal that value that was to the right of the log, the big number to the right of the log. So down here, you'll see all that terminology written out. You'll see that when given something in log form, we call that base number b, and the exponent it needs to be raised to is the value on the right-hand side of the equals, and that's going to equal this value of n. So there it is, the equivalence, because again, using this idea of the circle of life, b to the power of a equals n. One of these is log form, and then on the right-hand side, this is what we call the exponential form. So you'll have to know how to go back and forth from one to the other. Now, if you are ever given a log and there's no base written out, the base is 10. So I always remember this because this kind of looks like a 10, right? Can you see a 10 there? So if there's no base number, you can fill in a little base number of 10. Little fun fact, we used to teach you guys more with the natural log. This is going to make no sense to you at all for right now. But there is another type of log called a natural log, and the natural log has a base of e. If you guys remember from a couple weeks ago, we talked about e when it says compounded continuously. Just a little fun fact for right now, if you ever have the natural log and there's no base there, there's a little e. You don't need to know that. We're not going to focus on that for this year, but I just wanted to show you that because there is a quizzes question later on that you're going to be asked about the base of a log, common log. We call this the common log. And then you're going to be asked about the natural log and just knowing that the base of a common log is 10 and then the natural log, the base is e. Now, I would like for you to pause the video and try the you-try problems, and then when you're ready to check your answer, please restart the video. All right, let's see how you guys did. So for part A, you should have 3 or x equals 3. For part B, you should have had 4. And then for part C, you should have 5. So again, think circle of life. If you're struggling, 3 to what power is 27? Either think about it or get that same base. Same thing with part B. And then also for part C, same thing, where you're thinking 2 to what power is 32? Either get the same base or just think about it. Moving on, we are going to talk about specific types of exponents that you might encounter as you do these evaluating log problems. 3 different properties of exponents that we wanted to discuss was the 0 exponent. Remember, anything raised to the 0 power is 1. The negative exponent. Remember, negative exponents mean reciprocals. And then the rational exponents, which remember are the same thing as radicals. So the next set of questions are going to deal with these types of exponents. If you guys look at the answer or the question part A, you're going to see 16 to some power equaling 1. 16 to the x power equals 1. If you remember your exponents very well, you should remember that anything to the 0 power is 1. If you don't remember that, you're going to be really struggling with this one to get the right answer, because you would want to get the same base here. And the only way you can do that is by remembering that 16 to the 0 power, anything to the 0 power is 1, in order to get that answer. So this is really just a fact you have to have memorized. Anything to the 0 power is 1. For part B, again, knowing your exponents, 2 to what power is going to equal 1/2, you need to remember that 2 to what power is 2 is just 1, but if I want the reciprocal, I'm going to make my answer -1. Again, you can get the same base, but it's really just a factual thing. You need to remember that anything raised to a negative power means reciprocal to get that answer. For part C, it kind of takes that idea and goes a little bit further with it. 2 to what power is 1/8? Well, if you remember 2 to what power is 8, you would say 3, but because we want the reciprocal answer, we would get -3. Note, you can also get the same base, but again, you would just have to know that 1/8 is really the same thing as 2 to the -3rd power. Moving on to this next one, you can rewrite this as 36 to the x power equals 6. This one might really blow your mind. So again, get the same base. 36 is really 6 squared. Put a little 1 here. So I really get 6 to the 2x power equals 6 to the 1st. If you guys remember, power to a power, we multiply the 2 with the x. If I set these exponents equal to each other, note that I get 2x equals 1 or x equals 1/2. If you go back and think about it, you might not have to do any of this work, because if you know your exponents well, think about this. 36 to the first power is 36. It's too big. 36 to the 0 power is 1. It's too small. So I need to come up with an exponent that's between 0 and 1. So we're talking about fractional exponents. I'm thinking square root of 36 is 6, so that's how I can get that 1/2 as my power. Moving on to the next one, same idea. You can rewrite this in this exponential form and then get the same base. Think about 27 as 3 cubed. Then we can use the properties of exponents, and because we have the same base, we can now set those exponents equal to each other to get this answer of 1/3. Again, for some of you, you might have been able to get it right at this step. If you think about 27 to the first power, too big, 22nd to the 0 power, too small, I need to get an exponent in between 0 and 1. Well, it's not the square root of 27, it's the cube root of 27 that gets us 3, and that's why x has to be 1/3. And then for part F, remember this idea that if you see a log with no base, remember this looks like a 10, we get a 10 there. So think 10 to what power equals 1? Well, as we already saw, anything to the 0 power equals 1. Now, we're going to put everything all together and do these final 4 questions, and then I will conclude with one final thing. For this next question, you are going to use the exponents to evaluate each log. So kind of just making sure we feel good. Feel free to pause the video too, try these out, and then check your answer. We're thinking 7 to what power is 1/49? So either get the same base or just think 7 to what power is 49? That's 2. And then because we want the reciprocal, x has to be equal to -2. Okay, or alternatively, 49 is 7 squared, but remember we need to use a negative exponent since we want the reciprocal of that to get the same base. For this next question, think about log. If there's no number there, there's technically a 10. So 10 to what power is equal to 1,000? Since I want 3 zeros, x has to be equal to 3. Or again, you can rewrite 1,000 as 10 cubed, and you get that answer of 3 since we have the same base there. What? Did my screen just freeze? I guess my screen is done with the notes. Let's go back to Notability. Let's try this again. Sorry, guys. Kind of makes the notes a little bit more exciting, I guess. We're living on the edge right now. Or not. Part C, we have 8 to what power equals 1. Do a few of these, you'll get them right away. You'll just remember, oh yeah, anything to the 0 power is 1. And then for this last one, you can think 25 to what power is 5. If you struggle, just write it in exponential form. And then from there, think of 25 as 5 squared, getting that same base. And then you can use your properties here. And then you can, can I highlight in black? Yeah, I can. Then you can set the 2x equal to 1 or get a solution of 1/2. Again, you may have saw that right away. 25 to what power is 5? 1/2. None of that work is necessary, but please do that work if it is something you need to get in order to get that answer. Final thing I wanted to just say, because you're going to see this, I know, in at least one of the activities, but if I ever said log base 2 of -4, and I said to find what answer makes this true, if you think about 2 to what power equals -4, this is not possible. Remember that if you have a base of 2, if you raise it to any positive value, it's not going to be negative. If you raise it to 0, it's going to be 1. If you raise it to negative exponents, it doesn't make the number negative. It just makes it the reciprocal. So if you ever see a negative number here, let me highlight because I have so many arrows now. These arrows are all over the place. Let me get rid of these arrows. If you ever see a negative number here inside of the argument, it would not be possible to take a positive value, raise it to some power, and equal a negative value.